Okay, name that graph. So we have a graph here that we want to write both a sine and cosine function for. And I've got 2 points, and it's looking like, just eyeballing it, that neither of these are at a high point or on a low point or on a midline. So it looks like I'm going to want to approach it by doing a systems of equations. Okay, so first though, let's always, we always want to start with doing the amplitude and the vertical shift. So it looks like it oscillates between 5 and -1. So when I find the amplitude, I'm going to say it's 5 minus -1 over 2, or 6 over 2, which is 3. And then that helps me. I can either go from the high point or the low point and go up or down or up 3. So it looks like the midline here is going to be at 2. So there's a vertical shift up 2. And it really doesn't matter in this case, again, since both a cosine graph and a sine graph are going to be, they're going to involve a phase shift here. So it doesn't matter which you start with, but it is very important to figure out, okay, what is my starting point? Meaning, what am I eyeballing for what was my original graph and how I transformed it? So for example, say I'm thinking about, again, it doesn't matter which. Say I'm thinking about a cosine graph. Normally a cosine graph would start at its highest point. So maybe I'll use this one and I'll say, okay, I'm going to do a cosine graph shifted to the left a certain amount. So I'm going to think of this as my starting point. And again, keeping in mind, all right, this is a cosine graph shifted to the left. Why is that starting point important? Well, when I think about what you do when you graph sine or cosine. You start at 0 and then you plot some points. To the right of 0, it's going up, like the angles are increasing. We go, if there's been no transformation, we think of like first quadrant to pi over 2, and so on to pi, 3 pi over 2, 2 pi. And then to the left of that starting point, there would be negative angles. The same here, like to the right of my starting point, positive angles, and to the left, negative angles. And I think of how cosine normally goes. So normally cosine starts at its highest point. If there was no transformation whatsoever, highest point goes to the midline, lowest point, and so on. So I would think of from the highest to the midline is quadrant 1 angles, right? Because this would, without a transformation, be pi over 2. Then quadrant 2 angles, quadrant 3, quadrant 4, and so on. But then when I plot angles to the left, remember I would do like negative pi over 2. So think of that as we've got negative quadrant 4 angles. Think of about going around the unit circle in the opposite direction. So at negative pi over 2, then to negative pi, so negative quadrant 3 angles, and so on. Well, that's how you plot these points here. Whenever you graph, that's what you're doing. So once I've figured out a starting point, I just want to make note of it and say, okay, anything in this piece would be quadrant 1, which means anything in this piece, when I plug it in, is going to correspond to quadrant 2, so below that midline. And then if I go to the left, I've got quadrant, so negative quadrant 4, negative quadrant 3, negative quadrant 2, negative quadrant 1, and then again, negative quadrant 4, negative quadrant 3, and so on. Because it's important to, when we plot in these points, you have to think of them relative to each other. So this 0.5 is more than a period away, and not only away, but to the right of the other point I have plotted. So they should differ in that way. When you actually set up your systems of equations. So that's super important. All right, so let's now start. And again, because the starting point, I had this right here, which corresponds to a cosine with a positive in front of the amplitudes, because starting at the highest and going down. So I'm going to say y equals 3 cosine. Whether you do bx plus c, bx minus c, doesn't matter. It'll all work out no matter what you do. Just be consistent. And then the vertical shift is plus 2. Okay, so let's plug in the first point, the 0, 1/2. So 1/2 equals 3 cosine. When I plug in 0 for x, I'm just left with c plus 2. And then let's isolate the cosine piece. So I've got, so subtracting 2, I get -3/2. Divided by 3, I get -1/2 equals cosine c. All right, so now, again, it's super important. Where does that point relative to my starting point? And I already labeled it. So this would be to the right of it. So it's going to be positive, a quadrant 2 angle. So I want to think, what quadrant 2 angle, when I take the cosine, do I get -1/2? And that's going to be 2 pi over 3. So boom, I already have my c value, 2 pi over 3. Okay, great. And now, so now let's plug in this other point because I still need to find this b value. Maybe I'll do blue here. Okay, so again, plugging in for x and y. So for y is 2 minus 3 root 3 over 2 equals 3 cosine, I don't know b, and I'm putting in for x, -7 pi over 6b. I just found c to be 2 pi over 3, so let's just use it. And then we've got the plus 2. Okay, subtracting 2, I'm going to get -3 root 3 over 2. And dividing by 3, I'm just going to get -√3 over 2, which is a ratio I know, which is good because I need it to be a ratio I know, so I can actually do this. All right, so now I want to think of all the labeling I did. So look at how far this point is from the other point, or how far it is from my starting point. So it's to the left more than a period away. So I'm going to think of the angle that this is going to correspond to. So this inside should equal -2 pi, because it's more than 2 pi away. And then what is the negative quadrant 3 angle? So over here, that corresponds to -√3 over 2. So I know that √3 over 2 corresponds to this a reference angle of pi over 6. And the negative angle that will land in that third quadrant would be -5 pi over 6. That would land me in that quadrant 3 there. So -2 pi and then another -5 pi over 6. All right, so that's going to be, so let's see. So -7 pi over 6b plus 2 pi over 3 equals -17 pi over 6. So let's subtract 2 pi over 3 or 4 pi over 6. So it's going to be, oops, I forgot my b. -7 pi over 6b equals -21 pi over 6. And remember, when we now solve for b, we're going to multiply by the reciprocal. So times -6 over 7 pi. Well, this is working out nicely because it's just going to be 3. All right, so one equation is going to be y equals 3 cosine 3x plus 2 pi over 3 plus 2. Okay, so that's going to be my cosine equation. Again, I decided to start with cosine, and this is like that's the hardest part right there, because now once I have that, if I want to find the sine equation, I can say 3 sine 90 minus, so pi over 2 minus 3x plus 2 pi over 3 plus 2. Okay, so 90 minus, the common denominator is 6, so it'll be 3 sine. So let's do 3 pi over 6 minus 4 pi over 6 is negative pi over 6. So negative 3x minus pi over 6 plus 2. But you can't, the convention is you cannot give an equation with b being negative. So I need to factor out a negative there. So I'm going to say y equals 3 sine. If I take out a negative, I've got 3x plus pi over 6. And then I've got the plus 2. And then, and then last thing is sine of a negative. Remember, sine is odd, which means sine of negative theta is negative sine theta. So that negative will come out in front. So negative 3 sine 3x plus pi over 6 plus 2. So that will be your other equation. So it's just so important to keep track of what you're eyeballing as your transformation. And again, I was thinking of a transformation left, and by the way, if I were to ask you what the phase shift is, remember to report the phase shift, you'd have to factor out that b value. So I would actually, if I want to think of the phase shift after the transformation, I would write it like this. If I factor out the 3, it would be shifted to the left 2 pi over 9. So that's the transform graph that I did. Again, I didn't need to do that here, but just in case it's asked, what would be the phase shift or the horizontal shift? And it'd be left 2 pi over 9, because it's always the shift after you've done that period change. Okay, hopefully that was helpful.